This is Deborah Taveras with StopTheCrime.net and Paul Power, the founder of the Primary Water Institute, PrimaryWaterInstitute.org. We are going to be discussing this illustration that you see before you now in detail, which is a description of primary and secondary water cycles. It shows how the mantle of the earth contains H2O. We're going to be talking about the primary water hydrologic cycle driven by Earth's energy. Primary water is created deep within the earth from the synthesis of hydrogen and oxygen under tremendous pressure from the Earth's internal heat. H2O in the form of vapor is forced upward through rock fissures, which are the weakest areas of Earth's crust, becoming liquid as it cools. Primary water is forced upwards, while atmospheric water is subject to the effects of gravity and flows downward. We're going to be talking about this and starting at the left of this primary water and secondary water cycle illustration. And Paul will be joining in the detailed description of what this illustration is showing you. So when we look at the left, Paul, we're seeing at the furthest left a dark line, and it is entitled Natural Primary Water Spring.
Yes.
So that is showing that a spring is coming up deep within the mantle of the earth, and it is primary water. Is that right?
That is correct. Actually, the manifestation of these springs, they are quite common throughout the world. Sometimes they manifest on top of mountains, sometimes in the valleys, sometimes in the middle of the deserts, middle of such deserts as the Sahara, at which point nobody ever asks the questions of what are the oases are all about. They are obviously not a collection of waters that are gathered from a high or a place many thousands of miles away, but in fact there they are. Suddenly, sometimes they emerge in the middle of the desert, in Sahara and elsewhere. We're in places where they shouldn't be. There shouldn't be any water there. There's no water coming down from the sky, yet they come up. Now the illustration on the poster, where it says where it indicates natural primary water spring, attempts to illustrate how such waters rise from down below. It makes no difference whether they're on a flat area like it shows on the picture, or on a higher structure, top of a mountain, in different places. But nonetheless, they do actually are forced up from down below. They are forced up from down below. And the next one that says primary water well at depth of say 200 to 800 feet, well, it could be from 0 to 800 feet. It hardly matters, because if one is to drill into that same faulted structure, as the illustration so tries to explain, one could encounter this water at any one given depth. It doesn't have to go 800 feet or 1,000 feet. It could be anywhere from zero to whatever.
Now, Paul, let me ask you, because I'm
Sure.
seeing a small dark line between the first illustrated line, which says the natural primary water spring that you just spoke about, and then I'm
Yes.
seeing a small line with a little yellow situation at the top of that dark line.
Well, that attempts to illustrate the drilling rig that is drilling into that fracture. That is what it tries to, what it attempts to do. It attempts to show how you can access that water by drilling into it.
Okay, and then that third line in, which says PW for primary water well, at the depth of 200 to 800 feet.
That's the same one. That's the same it tries to explain that that particular yellow thing there with the black line into the fracture, it can actually access water.
Okay. Then we're seeing an illustration of rain coming from a cloud over some buildings.
Yes.
And that is, of course, illustrating the secondary water cycle.
Indeed.
Okay, so as we move along to the next line that is entitled permeable surface, could you explain that, please?
Well, that is basically most of the structures that are occupied by habitation, like cities, etc., where you have so much topsoil and soil. Period. In other words, permeable soil, that is unsorted material that could be anywhere from crushed gravel to sands to soil that will have eroded, oxidized on the surface from which we grow our food.
So what is your definition then for the listeners on permeable surface?
Permeable surface is that which has been on the, let's say it has been oxidized, and water can penetrate. Water may penetrate because the material is not sorted, not solid.
So it's void of concrete.
Yes, or solid rock.
Okay. Okay. All right. Then the next.
And consequently, it will permit penetration of water from the secondary cycle. You know.
Okay.
In other words, it permits secondary cycle circulation. In other words, you can evaporate it, or you can permeate it.
Okay, so it literally allows the secondary water cycle, which is from rain and or snow melt.
You got it. That's exactly correct.
Okay. Then we're looking at the next line that is entitled polluted aquifer.
Yes, well, that any aquifer that is trapped beneath this permeable material which we occupy, okay, has to be polluted because of our presence. I mean not necessarily a malicious presence, but we do occupy that space. So anything that we do, we throw away, flush, do away with, will find its way down to this aquifer.
So any pollutants from chemical companies, from
human beings, animals, plants, rotting plants, whatever.
Right. Okay. So then. So that would be like the injection wells that we've discovered that there are about 680,000 of them, where it was felt that
apart from injection wells, that is basically all the basin water from which we are pumping water out of. In other words, if you look at different areas in the San Joaquin Valley or any other place where you can measure a drawdown from that container, which represents that aquifer, it has already been polluted to some degree by surface occupation, be it humans, be it chemicals. Well, humans and animals are the ones that would be contributing to a pollutant.
So now we're looking at the next
illustration,
indicator that is entitled reservoir.
Uh-huh.
So we're talking about reservoirs also as being a secondary water cycle containment.
Absolutely. Even if they are constructed higher and above those structures that are subject to human occupancy, because they still receive their water from runoff, from rain, either rain or runoff. Most of our reservoirs that we consider that we use our water to drink, for drinking, come from those reservoirs.
So we're drinking essentially polluted water, which is why there's the huge push for water treatment, when in fact all we have to do is access the primary water.
Absolutely. See, the thing is there's no way that we can drink the water. For example, any reservoirs that they say, okay, this is a drinking water reservoir. Well, my God, half of them are not even set aside entirely or exclusively for drinking. But you get recreation, you get all kinds of stuff that happens concurrently, even though the water is obtained from runoff. Now you have to treat those. You have to inject all kinds of stuff in there to make sure that that is not harmful.
Now, I wanted to just talk about the two circles in white that are on this illustration.
Okay.
One is the larger of the two circles, the one that is indicating the lower levels of water and is indicated as the primary water cycle. Could you describe to everyone that's looking at this illustration what that white primary water cycle circle is intending to illustrate?
Well, the primary water cycle, which is, we didn't know how else to illustrate it any better than what we did, but the primary water cycle implies or expresses specifically that all water originates in the mantle in the first place. That is the water cycle that even before there was an atmosphere, even before water could be precipitated from the atmosphere, because we didn't have any atmosphere. All this water has originated from down below, and it still does. It still does, because you see, our ocean levels they are not the same as they were 5,000-10,000 years ago, and we have evidence of it. I mean, we have all kinds of evidences. But the fact is that they contribute to the total volume of this planet being the water planet it is. And even today, the total volume of our oceans and our water resources are in fact growing.
Okay.
I don't know if
I understand completely. Now we're looking at the smaller oval white line that is entitled the secondary water cycle, which is then everything that is literally a consequence of the primary water coming up from the mantle. And
in the first place, in the very beginning of time, it's biblical as well. So it's something that that somebody dreamt up. I mean, there's references to it. There are references to it.
So
the secondary water cycle came about because first the oceans and water was in fact made, and then the secondary water cycle came about because of evaporation.
So the secondary water cycle is also referred to atmospheric water.
Indeed, because it was evaporated from surface waters such as the oceans, lakes, because even today, all of our lakes and rivers and oceans will evaporate a volume of water due to the presence of our sun and heat.
So all of the containment of water that's on the surface, such as the oceans, the reservoirs, and the lakes, are all as a result of the primary water surfacing, and then and then becomes the secondary water cycle. So I think this is a terrific illustration in the sense that it is really showing people the two cycles of water. But really what we're talking about here is the originating cycle, which is the primary water cycle, which is, again, as we've discussed, the expression of all the surface water. So as we look then again at this illustration, and we have just talked about the reservoir and the dark line that indicates the reservoir, and we continue to move towards the right, we see another dark line that has runoff.
Yes, well now, you see where it shows the runoff, and as you approach further to the right, it shows up top of a mountain with some vegetation. Well, the runoff originates on the highest point. Any point that is higher than the lowest point will experience runoff. Well, that runoff could actually enter the reservoir, not the reservoir, but the runoff, that water, which is the polluted aquifer. Because you see, not only do we add water to the aquifer from the surface through the permeability of the soils, but also if on the top there are entrance to the lower portion of that aquifer. In other words, suddenly you have now two items that are commingling water. One comes from runoff, okay, and one comes from human habitation.
Mm-hmm.
Do I make myself clear? I don't know if I...
Yes, you do. And also then we have the atmospheric pollutants as well.
Yes, indeed. Anything that comes from the atmosphere. And then, here it should be emphasized that radioactivity is one of those things. So we are now polluting that, basically, that aquifer that right now we think that we are really using, and we are using it. Of course, it's one of the best known sources, because you see it's got a stability in a sense that it is a bathtub-like, or it has a given volume. You could measure it.
So in essence, the secondary water cycle is, as we now know, literally polluted water that is on the surface, and that is what we know to be our drinking water.
Indeed.
So we're drinking polluted water.
We are.
Okay, so now we go on top of that first mountain peak as we're working our way towards the right. And as you just discussed, we see the atmospheric runoff due to what is being illustrated as a cloud and a downpour.
Indeed.
And
then you see a highly purged water, could be a lake, anything, but it still derives its source not necessarily from human habitation, but still it's polluted from the surface by whatever happened on the top, and also by that which is being recycled from the atmosphere.
So we're seeing that lake, as you had said, again.
That's very pristine and very pure, but it is not pure enough.
Yes, because it still exists because of the secondary water cycle.
Indeed.
Because I'm not seeing any fissures that look like they're going into that.
Correct.
Into that
and that's
basin.
one of the reasons. That's one of the reasons it was delineated, and also it shows another aquifer from runoff, but it still is from the secondary cycle. You notice that where it says
I do.
Aquifer?
Yeah.
Okay. Well, that is still definitely the quality is definitely negated by the fact that it is an atmospheric in origin.
Okay. So now we go above where it says aquifer from runoff, and we go to that mountain that has the green vegetation on it, and the arrows are going up, which is looking to me like that means and indicates water evaporation.
Indeed. Anything that is on the surface will evaporate. If it contains any moisture, it is subject to evaporation.
So is it fair to say when it evaporates, it's polluted water that's evaporating that is then coming back down and getting even more highly contaminated?
Well, indeed, because if it is filtered through the permeable surface, which is contaminated for sure by our presence, and also we have managed to contaminate the atmosphere with radioactivity, so we are actually adding radioactivity to our water source from nuclear problems.
Okay. So now as we work our way down into that next lake runoff and primary water, we're seeing then how primary water can influence the surface water by actually coming coming up from the mantle and injecting primary water into what is also being collected as a lake runoff.
Okay, and then that water is commingled. You could make the same case, and now in retrospect, we should have shown also on the very front of the picture where we are showing natural springs, etc., how that water too is actually commingling with the polluted aquifer, because everywhere where there's an aquifer, primary water is commingling with that aquifer. There's no two ways about it. There's no way out of it because everything is faulted, everything is fractured.
So it's the process of pollution and dilution of the pollution.
You got it. You have a situation where surface and primary waters commingle.
Okay. Then we're looking at all of these fissures that are coming up all along the base of this the mantle or the mountain range, as people would view it.
Okay.
That's an expression of the constant and continual availability of the primary water as it is continually and constantly surfacing.
Well, in places, as you notice, below that next peak, it is not surfacing in any shape or form because it's not surfacing in the shape of springs or anything. Now, when you go farther over, okay, and you start to looking at those little yellow things meant to illustrate drilling rigs. You can access those waters that are trying to surface.
Okay, so
horizontally and vertically.
Okay, I see that. Now, what I'm looking at then is that third peak going to the left that has the second cloud over it showing the rain falling on the peak. And then I'm just looking to the right of this peak, and I'm seeing what you're showing as a horizontal rig with a dark line going into the primary water fissure that's coming towards the top of that peak.
That's exactly correct. So you could access that at any given level.
Then, as we work our way to the right, just a little bit here, we're seeing again the yellow indicator of the drilling rig and the dark line that is going down vertically into that fissure and also accessing primary water.
It's not the same fissure, but it originates in the same place.
I see that. I'm glad you pointed that out. So they're both getting into primary water in different fissures. One is horizontal and one is vertical.
Right. It depends on the setting, and it depends on the logistics. Can you drill it this one horizontally? Is there a place where you can put a rig? Because obviously there are many springs too that were acquired by drilling horizontally into these structures that are still flowing. They have been flowing for the last, ever since they were hewn into the mountainside, as it were. And because in the old days we didn't have rigs. We didn't have drilling rigs like that. We do now.
Okay. So then as we move along to the right, we're now looking at the ocean.
Okay.
And we're showing evaporation with the arrow that's pointing up.
Uh-huh.
And we're also showing fresh water springs and wells that are... Vents, okay.
Yeah.
Yes, okay. So where it says fresh water springs and vents. And those are actually then commingling, as you say,
yes,
the primary water from the mantle of the earth up into the surface water, which is the ocean.
Well, the difference, you notice it's not as dark blue as the other ones. Is that meant to illustrate that the water actually, most of the water came originally from a primary source, but it is in fact salty. But that is the best illustration of the total volume that we can imagine, how much volume came in at once. But more water is added to it. And even today, as we speak, there are places on this planet like for example off Hawaii in several places where fresh water does come up out, you know, let's say, not let's say, some places it's as close as 50 feet from the shore in salt water. And the people that live there, they go in there, literally capture that water in bladders, that fresh water, because otherwise they don't have rain. They have no other sources of drinking water. So they figured out that somebody found out that this fresh water is coming up. So they are capturing that water.
So now, would it be true or possible that if they knew that they could drill for it on that island, and obviously it would be determined how much money it would cost and the availability?
Yeah, you could do it, but you would have to exclude the salt part of that water. In other words, you'd have to go ahead and have a barrier first to create the column.
I see.
So but that's all, and that will happen. I'll tell you, before this is all said and done in the next 20 years, there are many islands out there in the Pacific that in fact rely entirely on rainfall for their sustenance, and they are in fact sitting on all the fresh water there is. However, they are unable to reach it because many of them are coral in composition, so they will have to exclude all the surface salt water to enter those boreholes where you could access fresh water into solid, unsorted solid volcanics.
Well, that's interesting because, of course, Aruba would be an example of an island. And when one goes to Aruba, they see the cistern system that is on every roof, capturing the secondary water because of the inability, I guess, to access the primary water. That's what you're talking about?
Indeed.
Okay.
Indeed.
Okay.
The whole thing is that there are literally hundreds, if not thousands, of islands in the Pacific where the native people have you know, they have to capture rainwater in order to sustain themselves. Now the problem, of course, is now getting increasingly atmospheric pollutants which come from radioactivity. You know, like Fukushima.
Yes.
You know, those waters are in fact not healthful in any sense of the word.
Now let me ask you a question. We're moving our way. We're looking at the ocean right now,
Okay.
and then we're to the right of where we're looking at a fissure coming up, but it's not exiting into the ocean. What is happening with the force of that water attempting to literally surface when it's not able to surface?
Well, it is contained. It is contained and is forced backwards. In other words, that structure is not open to nothing. It's just sitting there, basically under the same pressure as the overall mantle. You know.
So it basically is like a river that's encapsulated.
Yeah, it's capped. It's capped water. Basically, it's
okay.
It could be used. It could be used. It would be obviously. Sensibility would suggest that it should be tapped for human consumption instead of just permitted to come into the bottom of the ocean. In other words, we get such an enormous volume of water down below that is good water, fresh water, and good in every sense of the word. That is simply adding to the total volume of the planet's water. This water planet is actually growing in size, and it will be growing in size for some time.
Now let me ask you, when we see a capped fissure that is not able to surface...
Well, it's not capped, it's just never surfaced.
Yes, okay. Is it then better to allow it to exit, to reduce the force of that water against the...
Well, you know, it makes no difference. You know, this planet... This planet provides for us to use, you know. It makes no difference to the planet whether we use it or we don't use it.
Okay. So then we're moving along to the right, and we're seeing this mountaintop where it's a volcanic eruption and release of
Yeah.
water vapor. Could you talk about that?
Well, there are simply no volcanic eruptions known anywhere that are without water vapors, which is a further proof of the fact that in an unsorted fashion, the magmas, when they surface in the form of eruptions, volcanoes, they bring along with them a yet undistilled, unseparated amount of water in the form of steam. Okay, those waters are trapped in such configuration that the only time they can be released is when you have an eruption.
So is that similar to the thinking of distilling water and then it comes back down as water at some point?
Distilling water would be more like you would have to heat. Well, yes, you could make a case for that, but this is at any rate with the magmatic material that comes out from down below, there is water trapped also. Mm-hmm. So along with the eruptions, you always have water.
I see.
And it doesn't have to be in the middle of the ocean. It can be anywhere. Whenever a volcano erupts, it will erupt, and also it produces a great deal of steam.
Yes. So.
And when it doesn't erupt, we have hot springs throughout the world, all over the place. The water and the material comes up so close to the surface, and quite frankly, I yet to understand the logic of Yellowstone's explanation of how this water comes up from the sky, and then an Old Faithful will erupt every so often, 2 or 3 times a day, or whatever. Well, now it seems to do that whether we have any water from the atmosphere coming down or not. So the point is that those waters in these hot springs, whether they are geysers that are intermittent, such as the Old Faithful, or not, or the geyser in Nevada.
Oh yes, the Sky Geyser.
Yeah.
That was as a result.
They are, whether they are intermittent or not, they contain minerals and they are hot. Invariably, they are hot because they are driven by the differentiations of magma, where oxygen and hydrogen is permitted to make water. At the same time, they are driven by the heat and the forces from down below. So thus they can manifest. Invariably, those springs are also radioactive to some degree or another. In other words, invariably, if you have a surface emanation of primary waters, specifically if it's hot, it invariably will have an element of radioactivity associated with it. Now, be it radium or be it strontium, etc., it all depends on where it is associated and where it is in relation to a whole lot of things.
Well, I know that some people have been taught to think of rainwater as being distilled water. What would you say to that?
Well, in fact, it is distilled water in a sense that it has to evaporate. See, water has the unique property of turning into gaseous, steam. In other words, if you subject well, of course you can verify that in your own backyard or in your kitchen. If you put a trap over a container of water, container with water, you will note that it will want to steam. Now that is evaporated water. That is water that is pure in every sense of the word. There's nothing else in there. It doesn't carry any minerals with it that would otherwise be associated with those waters that are coming from down below, that have to find their way up, and especially in a heated form, they tend to dissolve minerals and carry those minerals with it.
Okay. Now, I found it very interesting and a very important definition of what hydrogen means, because you had referred me to the definition. And I was surprised what we have not been taught in school. And certainly when you look at the Greek definition of hydro, which means water, and then you look at hydrogen, genes, it means water forming. So when we really look at what hydrogen is, and we realize that it is an element, and it is one of the most prevalent elements on the planet.
Well, probably in the universe too. Now they're finding all these ice cubes floating around them. You know?
Yes. Well, so we have plenty of water. So now we're looking at this illustration. We're moving down from what we see as the volcanic eruption. Mm-hmm. And we've talked a bit about the surfacing of primary water and how that then comes about in many areas in the form of hot springs.
Okay.
And then we're moving along down that mountain. We're seeing other fissures that are encapsulated. They're not exiting. And then we're seeing where it says fault lines filled with primary water. And then we're seeing some yellow lines coming out from the far right of this illustration and somewhat going vertical, but not necessarily.
Well, they could be. Those are basically those are also fault lines, but they really intended to illustrate shear zones, and that can happen any whatever directions. We just didn't want to have them put onto one single area where you couldn't refer to them.
Now, when you mean a shear zone, could you explain that?
Well, when you have these earthquakes, you know. In other words, the material, the solid material, is sort of bouncing around. It depends on which way the push comes from, what direction. Portions of it could break off and pushed forward one direction or another, upward, sideways, so forth. They are not faulted lines in the real sense of the word that they are vertical. They are in fact horizontal. They are faults also, but they are a result or a consequence of activity from down below, indirect activity, I should say.
Now let me ask you a question that I've heard other people question as well. If we were to allow more drilling of wells that actually was intentionally directing the intention of those wells towards primary water, would it reduce some of the stress of the water trying to exit that hasn't been able to, and to perhaps reduce some of the earthquake zones a bit, take some pressure off?
Well, it could, but in a sense that it wouldn't stop Earth movements, because you see everything down below is under stress. What it would do is potentially mitigate major Earth movements. In other words, it would be better to create an earthquake that is, say, 2 instead of a 7.
Yes.
In other words, I'd rather live through 10 of them that are 2 than one of them that, well, first of all, it's not on the scale.
Right.
Than one of them that would be tenfold.
Right.
All at once. So basically, the argument on that one, the argument can go any which way, but it is a fact that by accessing these structures, you would most certainly effect Earth movement. But I would prefer to, as I say, for my own logic and for my own personal well-being, I would rather see them happening around 2 or 3, and then say, oh yeah, that's a result of this well over here. Then wait for a day when there's nothing there, and suddenly we get a one that is 7 or 8.
Well,
because because the whole planet underneath is very much alive. I don't know. Everybody always thinks that that this planet somehow ceased to breathe and live. You know, this planet is a remarkable place. This belongs to all of us. So all of us came from it, and we are going to go back to it also. And it doesn't particularly care what our opinion is. I think we have to take the effort and time to understand it better. I think we will be so much for the better for it.
Well, I agree with you, and sadly what we're hearing now in the media is the massive fear campaign that we have limited water resources and we have water scarcity, when in fact we don't. And
actually, if we really look at it objectively, today we have more water than we ever had on this planet, in every sense of the word. The point is that we don't always have the water in the places where we would like to have it if we rely on the secondary water cycle, because that totally relies on that which evaporates and other considerations. Yet the planet itself has enough water, potable water, locked up in it that could see us through even these weather cycles, which we have for many unknown reasons, be it sunspots, be it other activities that we don't yet understand. But we have absolutely more than ample water to see us through. In other words, we have a backup system, and that our backup system is this planet. And the resource it provides.
Then basically, we've been living in a false understanding of where water really comes from. It's very similar to thinking of flat Earth science.
Indeed. I must concur with that 100%, because this is the water planet. This is one of the few planets that have water sort of floating around. I mean, it looks blue from out of space, etc. However, we get all these icicles that are floating around, and witness the last ones that the Germans tried to put down this machine to check it out, and they landed it on a piece of dirty ice. That is
interesting. Well, I wanted to wrap up this discussion with a final question, because it's certainly what is being discussed as a reason to implement these emergency well drilling moratoriums, particularly such as the one that was recently implemented in October in Ventura County in California. They were saying that they had to stop drilling and reducing the groundwater table because of ocean intrusion. And the way I'm understanding it, and you could help please explain that, because we're hearing the conversation that the abutment of farmland and or land in general to the ocean is now finding increased levels of salinity, which is literally creating land that people can no longer farm on because of the high salt content. But I'm understanding that if we allowed these aquifers to recharge by seeking the recharged value from the primary water, that we would then create that force against the ocean, and the ocean would not then be filling in these vacant areas that could be recharged with primary water. Am I making any sense out of what I just said?
You make all kinds of sense. Specifically, Ventura County. If anybody in these Californias should understand better, it should be Ventura County. Ventura County in the Santa Clara Valley, which is a river that it's a major river. It goes into the Pacific Ocean, basically in Oxnard and Mugu. That is basically the Santa Clara Valley's basin. This is an ancient river basin. And because of farming, that basin, boy, they are and still are pumping water out of there like there would be no tomorrow. Well, much of that water did originate down below. Much of that water is primary in origin, but a good portion of it is secondary, which is atmospheric. And it is recharged from the surface. Well, now, if you take both, because there has to be a balance before you can take so much out of any, there has to be an inflow and an outflow into a basin, be it your bank account, and they like to refer to it as our future bank account, and how we are depleting it in the form of water. That's how they refer to it. Well, now, they don't even know where the hell their money's coming from. That's a sad part. Because a good portion of that water in Santa Clara Valley does in fact come, and they know that, it comes from the atmosphere. So what they have been doing in the past, they have been, whenever they overdrawn that basin, they have been pumping California water into that basin to recharge that system, even if there were drought periods, in order to maintain the ability of that basin to sustain itself and keep the salt water out. Well, now, you can accomplish that by getting that water out of the California aqueduct. At the same time, you could do that if you had water wells in structures that Ventura County is very well noted for. You could pump that same water and keep the water if that's how you want to distribute water. Because all this is nothing else but water distribution now. In other words, you could get water. And where is the water? Where is the cheapest? What is the cheapest form? What is the cheapest access for that water? Is it drilling some water wells farther up in the foothills of, let's say, in Ojai, in certain places into the Saugus Formation, etc., and then use that water to recharge? But it has nothing to do with the atmosphere. Or just go ahead and rob Peter to pay Paul, get the water out of the aqueduct system. And that's what they have been doing all these years. So now there's a problem in the Santa Clara Valley because their water tables are dropping, water levels are dropping, where the Pacific is definitely intruding on them. But this is nothing new. Hell, I've been watching this for the last 40 years.
So basically, it's the simple
yes,
logic.
It's a simple matter of recharging the Santa Clara Valley. The question is, where are you going to get the water to recharge that basin from, you see?
So it would be recharged from obviously primary water.
Well, that's what I would do. I certainly wouldn't. I mean, where you obviously don't have enough water now in the California aqueduct system. Okay, so what are you going to do? You're gonna now not let people farm because they are now drawing more water out of that basin, because there is a definite basin there that has the fresh water on top and the salt water on the bottom. And if you take too much fresh water out, here comes the salt water.
Well, Paul, I want to tell you that the primary and secondary water cycles are very simple for people to understand. We just have not been taught. And this,
I hope I didn't add any to the confusion.
No, actually, you explained it in great detail, an explanation that is very important so that people can understand where water really comes from. I really appreciate you explaining this illustration that you created in such detail as you have, because I think what this will enable is for more people that are finding they can't farm or they can't raise enough crops to pay their mortgages, etc., they will be thinking in terms of where the water really can come from. And that is, of course, where the water originates. And that's deep within the mantle of the earth. And we have plenty of water. It's in abundance. We don't have...
Forgive me, but you live there in the Sonoma country area. But that last earthquake should have been the wake-up call that there wasn't even there wasn't any more water there than anywhere else.
Now you're talking about the 6.0 earthquake that occurred in Napa, California.
Suddenly you had streams running again, and then everybody says, "Oh yeah, well it always happens that way." But wait until it slows down. Oh my God, that water has to come from somewhere. The total volume of the water that was extracted by Mother Nature and was given to the surface should have sunk that whole county by a couple of feet. in total. You understand? It makes no sense that people don't ask that, because yes, you have sinkholes. You can't take something from somewhere and not have a minus. And water is not compressible. Now, you can't compress water. That's what basically floats a lot of things. And well, take a look at the illustration.
Yes.
And down below, that's what it is. It's water. But the thing is, that county should have been a wake-up call. Somebody should have been looking at that. Instead of poo-pooing it and say, well, it always happens that way, but don't worry about it. 3 months later, everything will be back to normal. Either it will rain or the other reservoirs that were depleted just below the surface will be refilled. Yeah. So equilibrium will be reached. It is remarkable. It is remarkable that none of these august scientists are not looking at the situation, very quick to make pronouncements on who should not and who should do what.
Well, I want to really express my appreciation for your taking the time to explain this illustration of the primary and secondary water cycles, Paul. For everyone that's listening, you can go to, and we recommend that you go to primarywaterinstitute.org. Again, primarywaterinstitute.org. We also link to this information from stopthecrime.net, and you can find the primary water link at the top of stopthecrime.net on the home page. Paul, thank you so much for giving us a class today on where water really comes from.
Yeah, and I really would like to thank you and my team, including the person who illustrated that poster, because without it, this would not have been possible. And I really feel privileged that there are people here that are thinking and are doing.
Well,
so
I think
it has been a privilege, and I thank you.
Well, thank you so much, Paul, and we'll get this information out far and wide. Thank you again.
Bye-bye.